Alright, we're going to do an optimization problem. There's optimization, and this problem says I have a barn, and I want to build a fence around it. I have 100 yards of fence, and I want to build it along one side. So it's going to look like that. Now, we know this total is 100, and that these two sides over here are equal enough. Yeah, they're equal. So they can both be x, and this is going to be y. Now what we want to do is optimize the area of this. So my sheep have enough place to roam. Alright, so we know that 100 equals 2x plus y. Because we have 100 yards of this fence, and there's two x's and a y. That makes enough sense right there. We can also say that y equals 100 minus 2x. Because that's just moving this y over and that 100 over. And we can do that around an equal sign. Now, area is just a x times y, that's length times width, or yeah, but in this case we're using x's and y's. So we get, since we know that y equals 100 minus 2x, we can just plug in that area equals x times 100 minus 2x. And we can distribute that x, and we get area equals 100x minus 2x squared. Oops. Alright, there we go. Now, if we look at this one right here, we can find the zeros easier. If we set this whole thing to 0, we know that when x equals 0, that x right there equals 0, that the whole thing equals 0. And we also know that whenever this x over here equals 50, sorry, then the whole thing, then the inside of this equals 0, and that would be times this x, which makes the whole thing equal 0. Now that we have some zeros, we're gonna take the derivative of the area. So it was, let's see, area equals 100x minus 2x squared. So the derivative of that, really simple, is 100 minus 4x. And if we set this equal to 0, we find that x equals 25. Drop a fucking stylus. And we're still recording. Awesome. Yeah. Well, now that we have the... What do we have? We have that a prime equals 100 minus 4x, and when the derivative changes, x is 25. So we can plug that into the y equals 100 minus 2x problem, and we get that y equals 100 minus 2 times 25, which is y equals 100 minus 50, which is y equals 50. Now we can plug this 50 and the other 25 into the area problem, which was area is x times y, and we get area equals, when the derivative changes, and when y is 50. So we get 25 times 50, which is 1250. And since this is area, that's square yards. So, since we found that out using math without a calculator, that's how good we are, we get 25. What is that? 25, 50, and 25. These are x's, this is our y, and the area is 1250 yards squared. These are all yards. Alright, and that's how you optimize fence building for a barn, I guess.